Hello guys. I was trying to open my Zoom directly from my account, but it doesn't work. I hope people figured that they had to use the, at least for today, I don't know why, the Zoom link from that I sent from Blackboard. Okay, so let's start. What we're gonna do today is the substitution method, and hopefully we can. And we're gonna do some wet work, and also we will do some Riemann sums. Okay. This goes to cover. So let me share my screen. Our objective is to cover the. Our objective is to cover the first chapter of the book. So let me show you here. I'm gonna share the book. Open the book. Yeah, let me share my screen. And something happened to my computer that is not. Okay, so I'm gonna share my screen. I'm sharing my screen, but I'm gonna hide my view so I can modify my computer to use the screen. Okay. So what I want to show you is the book. So this is the book. You guys have this book. Is in the syllabus. Is in course materials. So what we talked last time was fundamental theory of calculus. We're going to talk today about substitution, and then we're going to go back and do approximation areas. Okay. So we're kind of going out of order because I like to start this way because I can talk about chain rule and all that. So I give you time to recover that information. So this is the fundamental theorem of calculus. You know, they have so many theorems. I kind of skip those because, again, this is topics from calculus 1. But this is one version of the fundamental theorem of calculus. That's part 1, and the part 2 is the one we saw. Last class. This is the part 2. That's the one that I'm interested. Okay. So you have more examples here. We did a couple of examples. You want to do more examples, you can go to the book and solve this exercise, this example, for example, and then that will be good for you. And there are more examples, so you can go and do more. Okay. You can have student projects, so on. So next section, I don't think I'm gonna. Let's see. Oh, this is basic integration formula. This will be good for you also practice. That's what we're gonna do today. In a second when we start doing web work. Okay. So you have some applied problems here with velocity. Those are things from calculus 1. Okay. I remember. That's a typical exercise on the final. Okay. We even use this problem to report. We have to report to Texas State to see how much understanding the students have in calculus. I remember we used this problem. I remember I had to grade 200 problems of 200 students. Okay, for this kind of problem. Okay, so this problem is important. So it's about how you connect velocity and calculus, or basically physics and calculus. So okay, so now. What we're gonna do now, so you see you have a lot, but you see it's probably too many exercises, but it's good practice. You'll see that with practice, you solve these problems in 2 or 3 minutes. And that's the objective, okay? So now we're gonna do today substitution. We're gonna start on this topic. substitution, okay? And this is basically the substitution formula. We're gonna go over that, and we're gonna do examples, but I'm gonna choose to do examples from Wedwork. So you guys, I having some questions like how can I introduce exponential or sine, or so we're gonna do that, our examples from Wedwork, so that way I help you to your homework. Okay, but you see, I want to show you the book, so you have a lot of exercises here. Okay, so let's start with the lecture. So this last time we did, that's what we did. Now let's call it lecture 1. Lecture 1. So the thing is, when I do this, increase the window, it looks funny. Anyway, okay, let's do lecture 2. I think we're going to do substitution and Riemann sums. Okay, we'll see how much can we do of Riemann sums. So on my computer. So what we're gonna do. So remember, you have the chain rule. Remember, we talked about that last time. So basically, we were saying that the derivative, right? We can say like this: the derivative with respect to x of f of g of x equals, and let me use I'm gonna combine the two notation because it's convenient, okay? Is the derivative of the big function, or not the big function, the outside function evaluated in the inside function times the derivative of the inside function, okay? So that's called chain rule, remember? And now what I want to do, let's see, I want to erase this. Yeah, my computer has problems erasing. I don't know why. Okay, let's forget about. Okay, let me see. Erase. Okay, now I see. Okay, so now look at this. This is chain rule. So this is calculus. Okay, so all of you did this, but now look at what I'm gonna do. I'm gonna take the integral both sides. Integral with respect to x and integral with respect to x. Okay, now what happened here? Something interesting that is going to happen is that if I make a substitution, okay, so if I do the substitution u equals g of x, right? So I will get over here the integral of f prime of u, right? Now, if I call this guy g prime dx as du, right? Then I will get f prime of u du. So I'm doing here du, the derivative of u is g prime of x dx. Now look at that. Thanks to this substitution, this becomes an easy and integral to find, right? Because if I do this, my antiderivative will be f of u, right? And f of u, right, is really, what is u? Is g of x. So this is f of g of x, okay? So this is very elegant because look at this. I have f of g of x on this side, and look at what I have on this side. I have f of gx ds dx. So basically, it's telling me that the integral of the derivative of the whole thing dx cancel each other. So these two things cancel each other. So this derivative, let's put it blue. This derivative cancel with the integral, and I got the original f of g of x. Okay, so that's kind of the philosophy of this substitution. So basically, what you really want to do is the first two steps. So the substitution method is this part, because now you can use formula. Right. Well, actually, you have to go all the way. Yeah, you have to go all the way. You have to go all the way. When you are solving a problem. Okay. So let's solve. Let's go to web work and let's start solving some problems. But let's do one first in the book. So I teach you how I want you to. What is that? So I'm going to show you how I want you to study from your book. So the way I want you to study from your book is the following. You look the example. Let's say this is your example. I'm going to write it down. Okay? So you need to find the integral of x squared 1 plus 2 s cubed to the 5 dx. Okay? So we want to solve that integral. So I stop looking at that. Let me see what people is saying. Sometimes people is confused. Okay. Yeah, I will take attendance at the end. I don't take attendance right now. And somebody, sorry, so you cannot see the chat. So somebody's asking me about attendance. I will check attendance when the video is over, because I don't have too much time, so I don't want to waste the time. So at the end, I go to Zoom and I see who attended and who didn't. Okay? For the people in the section, synchronous. If you are asynchronous, you don't have to worry about this. Okay? Don't email me more complaining. If you are in a section that is not meeting at a certain time, you don't have to worry about it. If you sign up for the section from 2 to 3:15, yes, you have to be present. Okay? Okay, let's solve this problem without looking. That's what I want you to do when you are solving your home, when you're in the book. Okay, and this is very good practice. So what I'm gonna do is solve the example 1. Let's say example 1. So we got the integral of x squared 1 plus 2s cubed to the 5 dx. So the first step you need to do or to worry about when you are solving this problem is what is u? You need to do a substitution. Okay, so you want to go back. The idea is that thanks to the substitution you're going to make, you're going to obtain one of these elementary ones that we got from the table. These ones. The integral of cosine, the integral of one of these element at this table of antiderivatives. Okay, so the idea is that thanks to substitution, we can use this table and the problem will be easy. Okay, that's the trick. Okay, so what do you guys think? What should be u? What do you think is u?
U is the
2x to the third.
1 plus 2s cubed, right? So what is du?
6x squared dx.
6 squared dx. Thank you. Okay. So what is u this? Because this is the inside function, right? I mean, you try it, and if it doesn't work well, you change it. But after doing it several times, you are really good at this. So you get equals, and now we got the integral. So here is 1 plus 2s cubed to the 5. So instead of 1 plus 2s cubed to the 5, what should I write?
U.
What else? U to the?
To the fifth.
To the 5th. Thank you. Now I have s squared dx. So I have a problem here because I don't have s squared dx. I have 6s squared dx. So what I do is so I need s squared dx. So I divide by 6. I get 1/6 du. Okay. And then x squared dx equals 1/6 of du. So that's what I'm gonna write. So I'm gonna write. Well, let me put it like this to be very pedagogical. 1/6 du, and my u is to the 5th. Okay. So now I take my 1/6 out. And you got integral of u to the 5 du. And now is the time that you use your table. So you go here to the table. You go here to the table, and you see I had to use this one, right? I had to use that formula. So that's the formula I'm going to use. So what is the antiderivative of u to the 5 or to the 5th?
1/6 u to the 6th.
U to the 6, what else?
Times the 1/6 outside.
Yeah, but also divided by 6, right? So the antiderivative is u to the n plus 1 divided by n plus 1. Okay? So I'm using this formula. We are using here that the integral of x to the n dx is x to the n plus 1 divided by n plus 1 plus c. That's what I'm using here. Okay? So let's not forget the plus c now. And now what will be the last step? What will be the last step?
Put your values back into the U.
Exactly. So my U, you see, my real problem is on X. My real problem doesn't have U's. So I'm not solving my real problem. My real problem has U. So I need to go back to my real problem. My real problem is 1 over 36, because I multiply the fraction. And then 1 plus 2x cubed to the 6 plus c. Okay. So now, so this is, I'm gonna do it this the long way, just for people to have the real understanding of this. No, actually, substitution is really important. You know, in differential equations, that's probably the method we do most. Okay, and we do it by head. A lot of people forgot, and they got that struggle. But when you are good at substitution, differential equation is gonna be 50% easier for you. So you need to do really good in this one than any other method. Well, the other method probably partial fractions, but substitution or partial fraction is probably the most important method for you in differential equation. That is probably a lot of you are gonna take probably that class. So how can I verify that this is the right answer? Because so far I just have a method, and who knows if it works or not. By fundamental theorem of calculus, the derivative of this guy, my answer, the derivative of this guy has to give me x squared times 1 plus 2x cubed to the 5th, right? Because that's the fundamental theorem of calculus. The derivative of this guy, the antiderivative, has to give me the inside of the function. Okay, something like this. Remember, that was one version of the fundamental theorem of calculus. Integral of f prime of x dx equals f of x plus c. That's fundamental theorem of calculus. So if I find the derivative of this guy, I need to get what I need. So, okay, so let's do the derivative. So that's what I was doing, derivatives last class. So let's verification. So verification. So we need to find that the derivative of, I'm gonna put the derivative of the derivative of 1 over 36 1 plus 2x cubed to the 6 plus c, the derivative of this guy. So I hear people taking notes. That's the right way to do this class. If you are not taking notes, I think you are wasting 50% of this, okay? You need to write notes right now. And the derivative of this is, what do you say? What is the derivative of this? Using chain rule. Nobody knows? What is the derivative? So it will be the derivative of the first one. So this is chain rule. So it will be 6 over 36 of 1 plus 2s cubed to the what? To the fifth. Times what?
6x squared.
6x squared.
The derivative of the inside. The derivative of the inside is 6x squared, because the derivative of 1 is 0 and the derivative of 2x cubed is 6 squared. Plus the derivative of c, but c is a constant, so plus 0. Okay, plus 0. So now 6 times 6 is 36, so 36. So my answer is x squared times 1 plus 2x cubed to the 5th. And turns out that is exactly what is right here, right? 1 plus 2s cubed to the fifth. I'm talking about, oh, okay, maybe I just need to show you here. This guy, right? S squared times 1 plus 2s cubed to the fifth, okay? So the derivative of this guy is this guy, okay? So do you see my circle? The derivative of this guy is this guy. And I just verify using fundamental calculus. So my answer is correct. So let's see what the book does. Go to the book, and you see who is smarter, if you or the book. So, and it's good because sometimes you do things different, you know. And you learn to be independent of the book. That's very important, especially when you are teaching. So this is you, that we did that, the you, we did all this, and then they need to evaluate between 0 and 1. Okay, so let's do that. We didn't evaluate between 0 and 1. So they're gonna evaluate between 0 and 1, and then they get their answer. Okay, so let's do that. Let's evaluate between 0 and 1. I got a lesson for me. I need to check that I didn't forget. When I solve my exam, I better make sure I don't forget that my limit integration. That happens a lot. So I forget my limit of integrations. And you know, it's no big deal. So I'm going to teach you how I do it. This is originally between 0 and 1, but when I do substitution, they change. So I don't care about that. I just say A and B. Okay? I don't worry about those. I do my substitution. I do A and B. And now when I'm here, then I need to do I go back to my original. My original is between 0 and 1. So I'm going to plug in. I need to plug in at 0 and 1. Right? So I plug in at 0 and 1. And now, since I have 0 and 1, then the C is not there. Okay. So I'm going to erase the C. So since I have an interval to evaluate, I need to put it there. So when I plug it 0 and 1, let me see where I can do this. Yeah, this is easy to do over here. So I plug in at 1. So get 136. And this is at 1, I will get 1 cube is 1, 1 plus 2 is 3. 3 to the 6 minus, and then you plug it 0. You get minus 136. Okay, so this is my final answer. So if you have calculator, you can just plug it in and find your answer. Since I know in the exam we're not going to use calculator, so I'm going to leave it like that. So you can leave it like that in your exam, and that's fine. Okay, because people can just put these integrals in the calculator. I mean, the Hewlett-Packard or so many, and then you know. It's not fair for the other students. So everybody's on the same condition. So this is the answer. Okay. Okay. So that's the way we do it. I mean, you can plug it in your calculator if you want, and we will get the same answer. That's the book. So the answer of the book is this one. You see 1 over 36, 3 to the 6 minus 1 over 6. I just put the 136 in these two, and then is the same answer. Okay, so that's the way. Something I like from the book is it gives you a method. If you want a method for substitution, it's here. So the strategy method. Look carefully at the integrand and select the expression g of x within the integrand to set equal to u. Let's select g of x as the gx is also part of the integral. Substitute ugx, du, g prime dx, and and so on. Evaluate the terms, write the result in terms of x. So you can follow this method, is what basically what we did. We did, we first find u, then we replace it, then we use our table. So 1, 2, 3, we use our table. And then we evaluate back the interval values. And that's it, okay? Okay, so let's go to wet work and let's solve some problems in wet work. Sir, say, yes? Question? Let me go to wet work. So course materials. So you guys have a quiz for tomorrow. For being the first quiz, I'm not gonna do log browser or anything. Just please go to wet work and start solving your quiz. You have unlimited time, unlimited tries. What important for me is you try to solve it. This is my control, so you are every week on time, okay? This is my way to force you to be watching the videos, reading the notes, checking the book. That's the purpose, okay? Let me show you the quiz. The quiz is this one. Problem 1 is a substitution, very similar to the one we just did. Then we have this one, and then you have some Riemann sums. So let's hurry so I can do that. No, well, actually, let me start with my Riemann sums because I'm afraid I cannot get it done. So this is just an example, and you see my other problems. The other problem you have is Introduction to Integration, and that's probably what you have for this weekend, okay? I extended approximation because I had some problems. So this is an integration by parts, yeah. You can do these two at the same time, so, but you need Tuesday. You can start approximations because I put some problems on approximations. The first 3 problems are Riemann sums. So you can start doing that. And then for those 3, you need to use calculator, okay? Or you can just write it down, and if you write the sum, Weber will accept it, okay? So let me go over Riemann sum because it's already 2:36, and then at the end we do some more Weber problems. So, so let me show you in the book again. Oh, better than the book, let me show you the other material we have. Remember, we have this material from, you have this material from UTRGV. So this was funded, so those are, this got money from NSF, I think. So this is important to use it. So we had done fundamental theoretical calculus, define integral, integration formulas. So we're doing now substitution rule. So let's do approximation ages. That's where we're gonna go back, okay? So you have here left, right, and middle, but we're gonna talk about left Riemann sum and right hand Riemann sum, okay? And you have a lot of videos here in case you wanna practice. So we're gonna do an easy one. Okay, so we're gonna do let me see what people are saying because sometimes people ask questions. Okay, yeah, people were answering my questions too. Okay, so let me go here. By the way, I'm gonna do every Friday I'm gonna make a video reviewing, not reviewing, like reviewing what we covered this week. But it doesn't mean I just like 5 or 10 minutes video. It doesn't, it's like a video to tell you what we had done and what you had to do during the weekend and what is coming, okay? So hopefully I don't get myself doing a lot of stuff. I don't wanna get you, 20 minutes video of just talking. So hopefully 5-10 minutes of reviewing what we did this week and what you had to do. Although all that information is the announcement, but sometimes you get confused or I don't explain myself very well. Since I'm teaching this class so many times, I mean, I teach this class 8 times, 10 times. So for me, everything is makes sense, but sometimes I'm not making sense because I don't explain very well myself. So let me do this one. So we're gonna do Riemann sums, okay? So let's change the topic and let's call it Riemann sums. Riemann sums. So by the way, Riemann is very important in history because Albert Einstein was going to these lectures. Einstein is not only a physicist, but he needed more new mathematics for relativity. So he started going to these geometry math seminars, and in a conference he saw Riemann research. And basically Riemann that's the calculus that we do, but on surfaces. So you see our geometry we're doing right now, our geometry is the real line. Or in calculus 3, you will do the plane or the space. So this is R3, this is R2, and this is R, right? Riemann did many important things in the calculus on surfaces. So what about if you do calculus on a donut or on a sphere like this? Even worse, what about you do the geometry or the calculus we're doing on a space? So for Einstein, when you put a planet, right, the space is curved, right? So it's not flat anymore. So somehow the light is coming and start making some changes, okay? So he needs a new geometry, and Riemann was the guy that taught him. He even used to say that any student of Riemann will understand better the geometry he was teaching than Einstein. So that's a really important guy, and that's what Einstein was able to use it. Okay, so but what we're doing is and also these are called Riemann integrals. The integrals we're doing are called Riemann integrals. Okay, Riemann integration. So this guy is very important in history. So what we're gonna do is Riemann sums, and something I haven't told you, but you probably know already, is that if you have a function, right? And let's say you're gonna do the integral between a and b, you can prove in mathematics that the integral between a and b of the function f of x is the area below a and b. Okay. So the integral between a and b of f of x, the area below the graph of the function. So that's the other part. Okay. So one concept is being the antiderivative, and the other part, an extraordinary. That's what this is famous, and that's what everybody has to take it. Every scientist, because engineers, people from chemistry, physicists, even math are scientists. Okay, so everybody doing science has to know calculus. You know, you cannot do, because you need the statistics. You cannot do science without statistics, okay? Or calculus, because statistics is going to use integration. So Riemann said, well, let's approximate. So let's say we don't know the antiderivative. Okay. So Riemann said, let's approximate it. Okay. So he said, we're gonna take, let's say we start A, and well, let's start getting concrete, because let's make an example. So this is, no, we don't talk too abstract here. Let's start talking. I'm gonna have to make it bigger. Let's talk about x squared. You know, our famous friend, x squared. So we're gonna do. We're gonna find the integral between 0 and 1. We're gonna find an approximation when the function is x squared, right? So what he said, okay, let's, since this is area, and I know the area of the rectangles, let's divide the interval. Let's divide this 0 and 1, let's say, in 5 intervals. So we're gonna do 1, 2, 3, 4, 5. So how can you do that? So you basically do, let's say, this space, this is how big it is, delta x, okay? This is gonna be b minus a over n, okay? So in this case, what is b, what is a? What is b?
B is 1. B is 1 and A is 0.
And how much is n?
5.
5. So n is the number of intervals I want, number of intervals. Okay? And a and b are the interval, right? So basically I just had 1/5 or 0.2. So this guy is 0.2. This is 0.2. Or you want 1/5. Yeah, let's talk about fractions. I know you guys don't like fractions, so let's talk about fractions. So we're gonna do 1/5, 2/5, 3/5, 4/5, and then 5/5. 1 is 5/5. Okay. So he said, you have two ways. You can start from the beginning and finish one before, or you can start. So let's say like this: I can start on the left, or I can start on the right. So what do you guys want to start? You guys want to start on the right or on the left? This is not it's not a political question, okay? On the what?
On the left.
Okay, let's start on the left. So if I start on the left, it's a little weird because I need to start doing my rectangle with the height of the first one. So my first rectangle doesn't have any height because it's probably clearer on my second rectangle. My second rectangle goes here and like this. So it goes like this, like this. Go like this, like this. And then my last rectangle starts, the height of my last rectangle is here and finish here. Okay? So I have 1, 2, 3, 4, 5 rectangles. That's correct. Okay? I started on the left, and they call it left. Let's call it left hand sum. Okay. So how is my left hand sum? So my left hand sum is gonna be this. The approximation of the area is gonna be the sum of those rectangles. So left hand sum is what is the area of each rectangle? What is the area of a rectangle? You guys remember?
Length times width.
Length times width. Well, let me say base times height. Okay, same thing, right? But just for this, probably makes more sense. So what is the base of the first one?
It's
one. Let me say the second one. What is the base of the second one?
1/5.
1/5. And what is the height?
You have to plug in 1/5 into the equation x squared.
So what is it? It's 1/5.
1/4.
1/5 squared, right? So yeah, so my height, you see my height, well, in this case, this one, right? My height is the function, the value of the function of 1/5. It's like we're in Texas, so this is a good example. You step on 1/5 and you shoot your gun, and when you hit the graph, that's how high you are. Okay, so you are hunting. Sorry, you are hunting. So you are go there outside and then stay on this point, and then you choose your gun, and then you got your bear or whatever you're hunting, and then shooting, and then you got it there. Okay. So this is the first one. The second one, base is 1/5, height is 1/5 to the square. The first one, the base is 1/5. How high it is? If you start at 0 and shoot 0, this one doesn't have anything. So that's why this is a good example for this. Plus, then you just keep going. 2/5. Sorry, you got the base. So I do on this one and this one. Now the next one. My base is 1/5. Right? All of them have the same base. And now what I'm gonna plug in here. What is inside of the square over here?
2/5 now?
2/5. That's correct. 2/5. And you just keep going. You see, this is easy. 2/5, then plus the next one is 1/5. Everybody has 1/5 base. What is the height for the next one?
3/5.
3/5 square. Thank you. So I'm going with this one, and then the last one. And that's when you need to know where to stop. Okay. So you do the last one is plus 1/5, and the height, you see the height is here. 4/5. So plus times 4/5 square. So if you wanna make it nicer, and that's how the books like to present it, this is good. By the way, this is, since I'm not using calculator in the exams, you can just leave it like that. If you plug it in like that in your whiteboard is gonna understand. But yes, practice your calculator for all means. Okay, use your calculator. You wanna use another program, go ahead. Okay, do whatever you want. But in my exam, you need to show me that you are plugging in the right numbers. Okay. If you just give me the answer and your answer is wrong, well, I give you 0. Okay. So you need to show me understanding. Okay.
Yes, sir.
Uh-huh.
So like on the exam, if we leave it like that, it's gonna be fine.
Good. Yeah, it's good.
All right.
And you cannot use calculator. So I'm gonna check that you can use calculator in your quizzes and your homework. Okay. Okay. So just get Just get used to see that people write it like this, 1/5, and then look at that. This is so easy. 0 plus 1/5 squared plus 2/5 squared plus 3/5 squared plus 4/5 squared. And that's it. So you just need to know where you start counting. Okay? So now, this is left-hand sum. So now we do right-hand sum. Now there is something else that we're gonna do on Friday. That basically we start on Friday the real calculus too, because this is kind of review because you saw this in calculus 1. I just can, I'm trying to be patient so some of you took the class long time ago, the calculus 1, or maybe you're coming from another place. Anything could happen, but on Friday we start doing the other method. We're gonna do Newton method and trapezoid method, and then that's gonna be part of this is really part of this class, calculus 2. So a little bit is different. It's not more difficult. It's just the extension of this, and that's what people use in programming. Okay. So my next one is right-hand sum. So let me do my function again. So I'm going to do a right-hand sum. Okay, so I'm going to start on 0. I'm going to finish on 1. So same thing. I'm going to do n is going to be 5. A is 0. B is 1. So my partitions are going to be 1 minus 0 over 5. So 1/5. I'm going to do this one fast. You see, now we have a lot of practice. So now I do my same partitions, 1/5, 2/5, 3/5, 4/5, and 1. Now, this is right-hand sum. So that means I start on my right. So I'm going to start on my right. So this is going to be my first rectangle. So, well, I need to do my black. So this is my first rectangle. And you see, let's say I touch it, okay? So you see, this rectangle looks like this area is gonna be over the real one. The other area was below. This area is gonna be lower than the real one. This one is gonna be, this is gonna be less than the real one, right? And this area is gonna be more, because every rectangle is gonna give me an approximation that is more. Okay, so for example, this one is bigger, this one is bigger, this one is bigger, and then the last one is this one. So you see the last one or the first one. So the first one is not 0 as the one before. So that is my approximation. So the right-hand sum is gonna be the area of the first one. So what is the area of the first one? What is the base?
1/5.
Times the height. What is the height? This function is x squared 2, right? The same function. So what is the height of this rectangle?
1/5 squared.
1/5 squared. Thank you. So that one is 1/5 times 1/5 squared. Plus the next one. The next one is 1/5. Base is 1/5 times what is the height of the next one? What is the height?
2/5 squared.
2/5 squared, thank you. That's 1/5 times the height of this one.
3/5.
3/5 squared. Then, so I invite you to draw because I have seen mistakes. You know, this looks easy, but unfortunately a lot of mistakes. So the next one is plus 1/5 of 4/5 squares. So question, am I done or not?
You can factor out the 1/5.
Second?
You can factor out the 1/5.
No, but it's still my question. I am done adding or I need to add something else? How many rectangles I need? I need 1, 2, 3, 4, 5. I have 1, 2, 3, 4. So I'm missing one rectangle. The last one, right? So what is the area of the last one? That's 1/5 of 1 square. Okay. Now I can factor. All that I can just look at it and I just write it down. But you know, too fast, too wrong, too furious. Okay. So you can be fast and furious because you did it really fast, but at the end you got it wrong. So it's sometimes not a good idea. So 1/5. So you got 1/5 squared plus 2/5 squared plus 3/5 squared plus 4/5 squared plus 1. Right? And that's my answer. Okay? That's good enough. So since it's for the exam, I need you to show me your work, not just plug in your calculator. In the web work, you need to plug in your calculator stuff. Okay? Okay, so let's go to web work. And then let's solve a few problems there. Here. So you see, you have to do this. So let me go to my problems here. Let me see how many people I have. 87. I think I still like I think 96 I have between my synchronous and asynchronous classes. Okay, so I'm missing 10 people or 9 people there. So it worries me because you know we're already doing a lot of homework. So some people hasn't even yet started my web work. So okay, so let's see. We do integration. So the problem one is easy. So what is the antiderivative of x to the minus 7? What do you guys say? Huh?
It's x to the negative 6 over
X to the
negative 6.
negative 6. What else?
Divided by negative 6.
Divided by negative 6. So look at how I'm writing, just for people wondering. So you can check answers, submit. That's good, right? So you see? That's fast. Next one, 10 to the T6. What is the antiderivative of this? 10 T to the
7
7 and then
over 7.
divided by 7. right?
Sir, do we have different questions in you?
No, everybody has different problems. I mean, basically same question, but different numbers. So you'll have, for example, yeah, but I don't want to go because then I don't want to solve somebody else's homework. But yeah, you probably will have one square root of u, or one four root of u. Okay.
Solve mine, sir.
Say again.
Solve my problem, sir.
Again. Yeah, let's solve this problem. Okay, I don't know what he was saying. So let's solve this problem. So let's do it here. So we have an integral of 1 over cube root of u, right? du. So we can change it to u to the minus 1/3, correct or not? What do you guys say, yes or no? Let's put example. Well, this is example 3 will work. Let me put here example 3 will work. So then we do, what do we do here? U to the, what do we get? If you guys talk, we do more problems. If you guys don't talk, I don't hurry. What is u to the minus 1/3? And the derivative of u to the minus 1/3. So we go, by following the formula, is minus 1/3 plus 1 over minus 1/3 plus 1, right? Because it's this formula, integral of u to the n du. This is u to the n plus 1 over n plus 1. Okay? That's C, no? So we get u to the minus 1/3 plus 1. What is minus 1/3 plus 1, guys?
2/3.
2/3. And this is 2/3. So what is this now? Instead of you 2/3, I got 3/2, right? 3/2 u to the 2/3, and actually everything plus c, plus c, plus c. Right? So that's my answer. 3/2 of u 2/3. Well, yeah, let me avoid to write all that. Oh, they don't write it down. Okay. So we said 3/2 of u. What did I say? 2/3?
2/3.
Did I say 2/3?
Yes.
No. No, I should say something else. Oh, sorry, guys. It's
We took the cube root.
3 times the square root of u. Oh, I did it wrong. Sorry, I make a harder one. So anyway, it's correct. I need to do the 1 over 3 square root of u. I think what people was telling me, when a lot of people start writing, it is because that. Let me see. Let me see the chat. Oh, okay. Problem 9. People's asking me problem 9. Okay. I'm just checking who texts me. Sorry, guys. I'm not gonna do this one. But the one that we supposed to do, I didn't solve the right one. Sorry. The problem here was to solve integral of 1/3 square root of u. U is similar, so we do 1/3 and 1 over the square root of u du. So I'll let you finish that one, okay? Let's say another example. It's very simple. I'll let you do. Yeah, I'm getting 1/2, so that's why I knew I was doing an alternate. Okay, let's do another one. Oh, this is easy. Probably not. It's 5 is more interesting. Somebody was asking me 9, so let's look for 9. 7. 8. 9. Oh, I see. So I see what she's asking. What she or he is asking me this. Okay, let's do number 9. This is interesting, yeah. And then this is 10. It's good. This is similar. This is all these are easy. Okay. Don't be scared. Just start solving your homework. So your brain is smarter than you think. You just look at it, and then somehow your brain tells you what to do. So you start working on your problems. So let me do number 9. So this is interesting. So it's a function. It's a step function. So you just split the integral between 0 and 1 for phi x to the a plus integral from 1 to 2 of 2x squared. So the right way to do it so phi x, so the integral between 0 and 2, so this exercise 5, integral between 0 and 2 of that f of x. So we split it. Integral between 0 and 1 dx plus the integral between 1 and 2 dx. And that integral is going to be over here. So phi x to the a and 2x squared. Phi x to the a and 2x squared. Phi x to the a and 2x squared. So let me check so I don't phi x to the a, 2x squared. Good. Sorry guys, I hope I'm not making you dizzy. So now we start integrating. So we need to find the antiderivative of phi x to the a. What is the antiderivative of phi x to the a? Somebody? Phi x to the
9.
To the 9 divided by 9, no? And then the next one, and then between 0 and 1. So we put here 0 and 1. Then we do plus. So let me put it down so it doesn't look that messy. You know what Messi is famous right now. Plus, what is the antiderivative of 2x squared?
2x cubed.
2x cubed divided by 3. And then this is between 1 and 2. Okay. So now we evaluate those. So let me evaluate it here. So we get 5 9s, because 1 to the 9 is 1, so minus 0, minus, so minus 0, so that's fine. So plus, evaluate at 2, there will be 2 times 2 cubed, right? So let me put 2 cubed over 3, minus 2/3. Okay. Okay, so this is 5 9s plus 2 times 2 times 2 times is 8 times 16 thirds minus 2 thirds. So I'm getting 5 ninths plus 14 thirds, right? But I need to add the fraction, so I multiply times 3. So I get 5 ninths plus 14. So 3 times 3 is 9, and 14 times 3 is 42, right? And then I get 47 ninths. 47 ninths. So let's, well, 1 minute to see if I. 47 ninths. That's correct. Okay. And with that, we finish the class. Okay. So if you guys have any questions, you can ask me now. Let's 5-10 minutes of questions. Okay. I'm checking here the chatting. Okay. So any questions? So you have quiz tomorrow, and because it's the first week, first quiz, and no, you just go away work. You have the whole day. I mean, you can start today. You know, can start today doing your 3 problems. And
sir,
can
you do a problem 5?
Problem 5. Okay.
Yeah, real quick, please.
Problem 5. Minus x and dx. Okay. So what you need to do, well, let me do it here. So let's do exercise 5. So we do the integral of 4 minus absolute value of x. Is that right? 4 minus absolute value of x.
-5 to 5.
Yeah, and between -5 and 5. Okay. So I'm gonna do it with geometry. Okay, so you guys see how it makes sense, and you guys learn doing your precalculus. So let's start with the function, the absolute value. So my function absolute value looks like this. This is absolute value of x. But this one has minus, so that means this function changed to like this. So this is minus x. But now I add in 4, so that means that I add in 4, so that goes 4 up. So it goes 4 up, so it goes like this. This is 0, so that goes 4 here, and then it goes like this. So this is 4 minus absolute value of x. So this is my graph. Okay? So, question for you guys. What is this point? Now, what is this point? When is this function 0? This function 0 is 0 at these 2 points. This point, what is not writing? Oh. It's in this point. Wow, I don't know why it's not writing. Okay, in this point. So 1 point is what? What is this point over here? Somebody needs to know.
4.
4, yes, that's 4. And what is this point over here? -4. Okay? Well, that's not important because my integral is between minus 5 and 5. So what I do, so really my function goes until here and until here. Okay? So I need to find the area from minus 5 to 0. Oh, sorry guys, I'm trying to erase. So I need to find the integral between minus 5 to 0 is here. So I need to find this area plus the other area that is from 0 to 5. Right? So I just use this function. So what is this function here? So it's probably, if, let's see, I will say that this line it should be 4 minus x. Okay, because oh no, sorry, that's 4 plus x, and this one is 4 minus x. Because if x is positive, right? So let's talk about 4 minus x. If x is positive, the actual value of x is x because it's the actual value of something positive is the same. So it's 4 minus x. And if x is negative, if x is negative, the actual value of x, what is it? By definition, the actual value of x is x if x is bigger than 0 minus x if x is less than 0. So if x is less than 0, I got minus x. So I got 4 plus x. And that's what in geometry I'm seeing, because the slope of this function has to be positive. So this slope has to be positive. So that's 1. And this slope is negative. So it's minus 1. Okay. So my problem is really easy actually. Once I deal with my absolute value, I need to break my integral between minus 5 to 0 plus 0 to 5. Dx and dx. So for the first one, I have between minus 5 and 0, x is negative. So I need 4 plus x. And for the other one, I need 4 minus x. Okay. So now I need to find this integral.
Could you factor out the 4?
No, because this is 4 plus x and 4 minus x. So I cannot factor because it's with plus and minus. So now I do the first one. What is the antiderivative of 4 plus x? What is the antiderivative of 4? 4x, right? What is the antiderivative of x?
X squared over 2.
X squared over 2. And that one is between minus 5 and 0. Minus 5 and 0. Plus 4 minus x. What is the antiderivative of 4? X. And what is the antiderivative of minus x? Minus s squared divided by 2. And this is between 0 and 5. Now we do, so we find these guys, right? I guess I'm gonna do it here. Let me do it. I'm gonna have to do it here. And we're gonna do, I plug in at 0, the first one, so 4 0 plus 0 squared is 0. Minus, I plug in 5, so 4 minus 5 plus minus 5 squared divided by 2. Right? Oh, and everything is with minus, so careful there. So I plug it, because I plug it at 0 and everything is 0. I plug in minus 5, I got 4 times minus 5 plus minus 5 squared divided by 2. And now the other one is, I plug in at 5, it'll be 4 times 5 is 20, and then I get minus 25 divided by 2. Right? 420. I hope you guys are checking. Otherwise, we might make a mistake together. Okay, so now we add these things together. So we do minus 4 times minus 5 is 20. So 20 plus 20 is 40. And then minus 25 squared. No square. Minus 25 divided by 2 plus minus 20, so minus 50 divided by 2. 25 divided by 2 minus 20 minus 50. No. So I'll get 40 minus 25. So my answer is 15. Well, let's see. Maybe you make a mistake.
Hi, sorry to interrupt, but I need to get going now for my next class.
Yeah, sure, please go. I mean, I just answered because he asked me, and
Okay.
please go ahead. Go ahead.
Okay, thank you. Have a good day.
That is correct. Okay. So it's long process, but it's a nice problem. Okay, so guys, I'll let you go. Okay. Thank you very much. So always you can go just at 3:15. Okay, don't worry about it. And I will just you just watch the videos. Okay. Attendance. Yeah, I will check attendance at the end. Once you are logging out, I check attendance. I'm not gonna check attendance during the class because I waste too much time.
Professor, do you have time for one more problem?
No, I had to go because I have another meeting. But I will have office hours today from 4:30 to 6. Or you can email me.
Yeah, I'll email you then.
You can email me or 4:30 to 6 today.
Sir.
Okay? Okay, bye guys.
Mr. Irwin.
Uh-huh.
Did you get my email I sent you?
I don't know. Who are you?
Samuel from the asynchronous class.
Not sure. What was the question? Oh, let me check. Do you want me to check now?
Yeah, I sent to you.